In Module 3, we're going to start talking about polynomials and radical expressions. So in Section 1, we're going to introduce what a polynomial is. So a polynomial is an expression with one or more terms containing a combination of constants and variables raised to all positive whole powers. So for example, x squared plus 2x minus 1 is a polynomial. It has variables and constants, and all of my exponents are positive whole powers. Something that isn't x to the 1/2 plus 2x to the -3 is not a polynomial. So whole powers means you can't have fractions. So you can't have fractions, and then you can't have negative exponents either. Okay. We also have something called a degree of a polynomial, which is the highest power of a term in a polynomial. So for example, the x squared plus 2x minus 1 is a degree of 2 because 2 is the biggest power. And it is important to know that the highest power does not necessarily have to be from the first term. It could be from any term in any order. So we're going to first determine whether or not an expression is a polynomial, and if not, explain why. So 4x cubed minus 3x plus 12 is a polynomial. Right? I have variables and constants, and I have all positive exponents. My next example, -3/x plus x squared minus 7x plus 10 is not a polynomial. And the reason why is our first term, the -3/x. -3/x is the same thing as -3 times x to the -1. So anytime you have a variable in the denominator of a fraction, it has a negative exponent. So variable cannot be in denominator. Our next example, square root x minus 1 is also not a polynomial. And the reason is the square root x. So when you have a square root or any type of root, that's when you get fractional exponents. So if it's a cube root, fourth root, fifth root, that's also a fractional exponent. So variable cannot be under root. Our last example, xy squared plus 3x to the 4th y minus y. That is a polynomial. You are allowed to have multiple variables. It doesn't have to just be x. You can have x, y, and z, a, b, and c. Any variable you can have more than one, and as long as they're all positive whole numbers in the powers, it would be a polynomial. Now we're going to practice finding degrees. So each term in expression has a degree, has a power, and then the degree is the highest one out of all of those. So 4x cubed minus 3x plus 12. So the 4x cubed has a power of 3. 3x has a power of 1, and then constants technically have powers of 0. So my degree is the biggest one, which in this case is 3. Okay. Xy squared plus 3x to the fourth y minus y. Now, if I have terms with multiple variables, you add the powers together to get the power of that term. So xy squared, the x has a power of 1, the y has a power of 2, so the power of the entire term is 3. 3x to the fourth y would have a power of 5, and y has a power of 1. So my degree is 5. 14x to the sixth minus xy cubed for 14x minus 1. So I have a power of 6, a power of 4, a power of 1, and a power of 0. So I have a degree of 6. Okay. And my last example, negative 12. That's just one term. Constants always have a degree of 0. It's also common to write polynomials in either descending or ascending order. We will typically use descending order. That's a very common way. So it's when you write the polynomial in order from highest to lowest degree. So most polynomials we're going to work with will be in descending order, and it's the order that we're going to want to work with. Ascending order would then be the opposite of that. When you write a polynomial in order from lowest to highest degree. We are going to practice writing in ascending order, but not a lot of the time are we going to work with polynomials in that order. So we want to write our polynomials in descending order. So the first thing is I need to figure out the power of each term so I know what order to write it in. So x minus 12x cubed plus 0.5x to the 7th plus 2. So we have 1, 3, 7, 0. So I'm going to start with the biggest, 0.5x to the 7th. Then the next biggest, the minus 12x cubed plus x plus 2. So it goes from highest to lowest degree. Then the xy squared plus 3x to the fourth minus y. We have 3, 5, 1. So we start with 3x to the fourth y plus the xy squared and then minus y. So sometimes you don't have to really do a lot to reorder it, and sometimes you may not have to reorder it at all. Okay. Now we want to do ascending order. So starting from the smallest, going to the highest. So we have negative 3y cubed minus y plus 1 minus y to the 12th. So we have a 3, a 1, a 0, and a 12. So we start with 1, then we have the minus y, minus 3y cubed, and then the minus y to the 12th. And then our last example, 14xy plus 3x to the 6th, 3x cubed y to the 6th, plus 4y minus 75. So we have 2, 9, 1, 0. So I'm going to start with negative 75 plus 4y plus 14xy plus 3x cubed y to the 6th. So let me know if you have any questions about polynomials, degrees, or writing an expression in ascending or descending order.